because of that change in bicarb. You add up the two vectors and you get a point that shows you the sum of the two vectors. So that essentially in that wedge are all the different values of changing bicarb in order to compensate any type of PCO2 value in acidosis or alkalosis. That works there? Yeah. So we left with two, as you can imagine. Let's do one right here. Here I have a metabolic alkalosis. And as I have a metabolic alkalosis, I have high bicarb increasing the pH. And I'm going to remind you, then I'm going to say, so PCO2 must increase to bring pH towards normal. So now I'm going to hit a little snag. How am I going to be able to show PCO2 is going up on a diagram that plots bicarb? Is there a link between CO2 and bicarb? Tell me. Is there a link between the amount of CO2 I retain and the amount of bicarb that's floating around? Maybe you can give me the French name for it. Right? That's the Chatelier thing. So look, PCO2 going up means bicarb goes up, but because it's bicarb from high CO2 and protons are made at the same time, pH goes down. So I'm going to be a point here somewhere in this wedge. And in this wedge, there's going to be the compensation of metabolic alkalosis. And of course, you're going to say it's partial until it gets as close as possible to 7.4. And then you would say it's fully compensated. So look, the final one is right here. Metabolic acidosis. You have low bicarb that lowers the pH. We're going to say, so PCO2 must decrease, essentially lowering the bicarb while lowering the proton and increasing the pH. And now you see that in this final wedge, you have the compensation of metabolic acidosis. And as you have this, once again, you could say on the diagram, anything in the middle of the wedge is partial, anything closer to 7.4 is fully compensated. So now that you have all your wedges covered, you know how to read a question that shows you that diagram. Essentially, in this diagram, look in our first question. You realize that my patient, first, I would make sure I have respiratory versus metabolic. And I realized that if I was here, that would have been someone with compensation of a respiratory acidosis. Here, someone with compensation of a respiratory alkalosis. I would be able to say that here is someone with compensation of metabolic alkalosis, someone with compensation of metabolic acidosis. And finally, if I am in these two wedges, this is a mixed acidosis, this is a mixed alkalosis.